Good afternoon. So welcome to the last lecture in their series, Stepping Stones in the Development of Modern Physical Thought. Dr. Julius Siegler is back with us today for the Manhattan Project and Robert Oppenheimer. So, and Julius has said that he's interested in doing some more lectures for us in the future, so that'll be great. I'll keep you guys in the loop on that. Yes, definitely. And I just wanted to mention that I am showing the movie Oppenheimer in 2 weeks. Week after next, it's a Tuesday afternoon in here at 2 o'clock. It's a long one, 3 hours and a little more than that maybe, but we've decided we'll take a little break midway. So, but if you're interested in that, I'll try to have some goodies for you, maybe some popcorn and candy like the good old days, right? With Debbie with her movie, so we'll make it fun. All right, so welcome, Julius, and I'll turn it over to you.
Thank you, Susan, and thank you all for foregoing outside activities on this lovely spring day. I apologize for the title that I chose, but I'm not going to say much about the Manhattan Project. And if you watch the movie, you'll see what you need to know about the Manhattan Project if you're not a technical person. If you're a technical person, then there are most of the books about Oppenheimer concentrate on the Manhattan Project and the making of the bomb. This is just a handful of the at least 15 different books that I'm aware of on Oppenheimer. The most comprehensive and the best one, I think, is the American Prometheus, which is the basis for this film that you'll see or you have seen. It's based very much on American Prometheus. Abraham Pei, I think, is an excellent book. The others have focused on particular things, usually the bomb and the politics of the bomb. So, with that, just a personal aside. His name is Julius Robert Oppenheimer, and as a person growing up with the name Julius in the Deep South, I was aware of Julius Caesar, and I was aware that my father and my great-grandfather bore that name, but I was aware at an early age of a famous spy trial that involved somebody named Julius. So when Oppenheimer came along and they would occasionally say his full name, I was curious long before I knew anything about who he actually was or what he did. But my intent today is to try to help you understand his impact on science, American science, the bomb aside. And that's where I'll spend most of my time, and I'm happy to answer questions about what I know about the bomb and other things if you want afterwards. But Oppenheimer was born in New York City, and somewhere I've got a clicker, in April of 1904. Okay, it's all right. We can do it another way. Well, that may help. Thank you. I keep forgetting about such things. I thought it was on, though. Let's try again. No, that's not what I want. Let's go back here. You see if we can get back to slideshow. Let's try this. There we go. Whoops, I lost my mic now. You can tell I'm an experienced lecturer. Anyway, his father was an immigrant from Germany, from Hanau, which was a city just outside of Frankfurt, who immigrated to the United States in the 1880s and founded a textile import business and became very successful. So Oppenheimer was born into a wealthy New York family, not really wealthy New York family, but wealthy enough to have a nice home with imported furniture, servants, and paintings by such people as Van Gogh, Rembrandt, and Picasso hanging in the house. He was a very solitary young man and very precocious. And he, as he was growing up, he really enjoyed studying minerals and writing poetry. The Oppenheimer family was Jewish, but they were non-practicing Jews, part of what was known as the Ethical Culture Society. That in itself is interesting. It's an outgrowth of American Reform Judaism that was founded and led by Dr. Felix Adler. And they placed a strong emphasis on social justice, civic responsibility, and secular humanism. Adler also founded what was originally called the Working Man's School, but became known as the Ethical Culture School, in which young Oppenheimer was enrolled in 1911 at the age of 7. He was a pretty sharp kid. He skipped half of the first grade, skipped another grade, and it was his academic prowess was very obvious to his teachers and to his family. By the age of 10, he was seriously studying minerals and the physics and chemistry of minerals. He entered into a correspondence with the New York Mineralogical Club, and it was so advanced that they invited him to deliver a lecture, not knowing that he was a 12-year-old boy. But I should warn you, if you delve into Oppenheimer very far, that you find very conflicting views of his personality and the person that he was. Some saw him as a spoiled kid, arrogant and pretentious. Others saw him as in a very different and more kindly light, and I'll try to shed a little bit of both aspects of it. But he was not a popular person, partially because as a young person he was very introverted. He once told a friend that if you ask me a question in Latin, I'll answer you in Greek, just sort of showing off. And he called himself, as an adult, a repulsively good little boy. He was bullied. And there's a tale which I can't track down definitively, but it appears in some of these biographies that at a summer camp, the other kids stripped him naked, painted parts of him green, and left him in an ice house overnight. So he, as a kid, withdrew into a world of poetry and science. And he once told his brother Frank, who was a well-known physicist in his own right, and in some case, a person I empathize with because he was a physics teacher more than a research physicist. He said, "I need physics more than I need friends." But he graduated when he was 17 years old. This is another picture of him as a young man, and you can guess that he might have been bullied a little bit in a regular setting. But as a high school graduate, he was rather handsome, very striking, with pale blue eyes, and that's something that you don't get a good sense of even from the movie. Very piercing blue eyes and thick, curly black hair. He was 6 feet tall, very thin, and he says that he ate mostly chocolate and artichokes. His favorite lunch as a teenager was what he called a black and tan, peanut butter toast with chocolate syrup. So, this young man graduated from the Ethical Culture School in 1921 at the age of 17. And as a graduation present, apparently he got a trip to Germany where he contracted dysentery. It became too ill to enter college that fall. So in the spring of 1922, his father urged him and sent him to New Mexico to gain strength through being outdoors. And while he was in New Mexico, he learned to ride horses and developed the lifelong love for New Mexican scenery that is very obvious again in the movie when you see it. He did camping trips to the Sangre de Cristo and Jemez mountain ranges. And at one of these, he rode up onto the Pajarito Plateau across the Valley Grande of the Valles Caldera, and then onto the isolated Los Alamos Ranch School. 20 years later, he would suggest that school be used as a secret laboratory during the Manhattan Project. So in the fall of 1922, at the age of 18, he entered Harvard. And he started as a chemistry major in Harvard. He really liked high school and public school and the ethical culture school. And he was using the chemistry to help him study minerals. But he switched to physics. He continued to write poetry and took a very heavy course load. He finished Harvard in 3 years. Recalling this time in his own writing, he said, "My feeling about myself was always one of extreme discontent." He studied mathematics and took courses in philosophy and Eastern religion, French literature, English literature, and was actually admitted to graduate standing in physics as an undergraduate on the independent basis of independent study as a high school student. He fell under the advisor. He had an advisor, a man named Percy Bridgman. And Percy Bridgman was a preeminent American experimental physicist in the early 20th century. He developed a way of creating extremely high pressures, and he's known for studying the properties of materials under very high pressures and very high stresses. And just to give you a sense of that, we live under an atmospheric pressure of 1 atmosphere. Common high pressure apparatus at the time could generate up to 100 atmospheres of pressure. His device could easily go over 100,000 atmospheres. And in fact, I had a question on my master's oral defensive thesis from Jesse Beams, who was a link to that period in American physics history, as to whether or not I thought that you could squeeze a solid so hard that there would be no space left between the atoms. As it is now, the atoms are spaced in some distance apart because of electric repulsion. I don't know what I said. I have no idea. It was a question that came. The same man asked me on my PhD distance just as I was getting ready to leave the room to speculate on how far a duck could fly. He was serious. I had to go through a calculation. Imagine a 3-pound duck and make some estimates about stuff. And anyway, that's an aside. Bridgman was a brilliant experimental physicist, and Oppenheimer graduated summa cum laude in 1925 with a degree in physics and a great deal of interest in moving to Europe. And the reason he wanted to move to Europe to study was that all of the innovations in physics at that point were happening in England and in Germany. So he applied to Cambridge, wanted to work for Ernst Rutherford at the Cavendish Laboratories. And that's the place where the electron had been discovered in the early 1900s. Ernst Rutherford and his students had demonstrated that most of the matter in an atom was concentrated in this tiny little part in its center called the nucleus, and that had begun to provide hints as to what the structure of an atom looked like, and that was in the physics news at the time. And the people in Germany were trying to understand the physics of the discovery and why it couldn't be and could be. There was just a lot of stir in Europe. So he Rutherford turned him down. Rutherford said that he wasn't a good enough experimentalist to handle what they were doing at the Cavendish lab. So J.J. Thomson, who had actually discovered the electron, agreed to accept him as a physics student. But he was not happy there. It turned out that he was not a particularly careful experimentalist, bored, and he almost was expelled at one point for misbehavior. There's a tale again that I can't verify, but the tale goes like this, and you'll see a quick reference to this in the film. You won't know what it's about, but apparently he and several friends from Cambridge vacationed one summer in Corsica off the south of France, and they hiked and biked and ate and had a good time. And one night they were caught in a storm, and they were chatting about stuff. One of them declared that Tolstoy was the writer he most admired, but Oppenheimer just shook his head and argued that Dostoevsky is superior. And the reason, he said, is that Dostoevsky gets to the soul and torment of men. And the students had become worried about him because he seemed really agitated and restless and wouldn't say why, what was bothering him. Well, what was bothering him was that he admitted to the students, supposedly, that he had had a violent disagreement with his tutor. Again, at Cambridge, you didn't have to go to classes. You had a tutor who actually taught you everything, and apparently he and his tutor did not get along, and Oppenheimer hated him. So he told them that before he left for vacation, he'd injected poison into an apple and left it on the tutor's desk. And of course, the friends were very upset by this news. And they just wondered, how could somebody wander around the island for a few days, unconcerned as could be about this, and then admit it? Well, that's sort of the Dostoevskian view of Robert Oppenheimer. Now, there are several questions. Question one, whether he really poisoned an apple. Question two, whether there really was an apple. But no question whatever about the fact that he was he absolutely hated this tutor. So he underwent his own volition counseling, as we would call it. He saw 3 psychoanalysts in a period of about 4 months. But himself, and again in his own writing, credited Marcel Proust's novel In Search of Lost Time with lifting his depression. And he transferred from Cambridge to Göttingen University in Germany. Göttingen is one of the older universities in the world, and one that perhaps is very little known in the U.S. for its accomplishments. Göttingen was the home of the greatest mathematicians, including Leonhard Euler, a generation earlier, and others that any math student would recognize immediately. But at the time that Oppenheimer went there, it was because of what was developing in the field that we called quantum mechanics. Max Born, a Nobel Prize winner, was there, and he was helping to develop the theoretical underpinnings that would explain what the scientists at Cambridge had discovered in the way the atom was put together. It was total mystery because it violated all the known laws of physics. It violated Maxwell's equations. There were all kinds of theoretical problems with it. So Oppenheimer saw that as really exciting, and he became a student and co-collaborator with Born. So this is 1923 roughly. This is the time, 23, 24, 25, was when Werner Heisenberg, who was at Göttingen, Erwin Schrödinger, Paul Dirac put together the theoretical basis of what we call quantum mechanics. I mean, this was happening as the time that Oppenheimer was there. Oppenheimer worked with Bohr to try to understand how two hydrogen atoms, how you could apply this quantum mechanics to two hydrogen atoms coalescing into a hydrogen molecule. And they had to make some guesses, some approximations, but they published a paper on the quantum theory of molecules. I'll call your attention to that in a few minutes. That was a breakthrough in using quantum mechanics to understand molecules as opposed to single atoms. The only atom that they could understand really was a hydrogen atom or a helium atom that normally had two electrons, but one of them had escaped, so it was basically the same problem. So Oppenheimer was awarded his doctorate in physics at Göttingen in 1927. He came back to the U.S., taught for a very short period at Harvard with Percy Bridgman, and then accepted a position teaching at Caltech, California Institute of Technology, in the summer of 1928. And during that summer, he returned to New Mexico to go on horsepacking trips with his younger brother Frank. And they were shown a rustic cabin for rent in the Sangre de Cristo Mountains. Oppenheimer leased it and eventually purchased it in 1947 for $10,000. It was jokingly named Perro Caliente, Spanish for hot dog. And so he had a permanent piece of his favorite state. This is his, I'm going backwards. This is his Harvard yearbook picture. And this is a timeline which you can't read, unfortunately, but you can see that at this point we are at the point where he joined the Caltech faculty, and in 42, we'll look at another list like this shortly. He is, or by then he had organized a program in particularly fast neutron physics, and that's important for the bomb. So this is where we are at this point in Oppenheimer's life. So in the fall or in the winter of 1928-29, he began teaching at Cal Berkeley, and had a joint appointment with Caltech. So he taught courses at both schools and served as a doctoral advisor in both schools. And he began to gather a really dedicated following of student admirers that coalesced around him. Berkeley by then had gained a reputation as a premier place to study physics in the U.S. because of Oppenheimer and the work of experimental physicist Ernest Orlando Lawrence. And that's Ernest E.O. Lawrence, as he's named on the right, and Oppenheimer leaning against the car on a camping trip in New Mexico in 1930 or so. And again, you can see Oppenheimer in this picture still has the bushy black hair. Lawrence won a Nobel Prize for creating a particle accelerator called the cyclotron, and during that same time, Oppenheimer was busy doing an enormous amount of original work as a practicing physicist. This is the rest of his timeline. We'll talk about some of it, but you can see that beginning in 1942, he began to be involved in projects that led into the Manhattan Project. The Fast Neutron Project was a project of theoretically describing how to generate fast-moving neutrons, what the difference in terms of various material penetrations, fast neutrons and slow neutrons and so forth were. But it was not until 1943 that became director of the Los Alamos Laboratory, and that part of where the Manhattan Project actually began. But you'll notice that he was also on what was called the Met Lab, which was, where's that? At the top, that's Enrico Fermi's group that led to the creation of the first sustained nuclear reaction, first reactor, in essence. So he was heavily involved in a lot of different theoretical research programs before the Manhattan Project itself formally existed. It's an interesting thing because during this time, this is the time at Caltech and at Berkeley, that's when he had a social circle of people who were very much interested in the Communist Party. And this is something you'll see in the film if you haven't seen it. It's well documented. But the interesting thing to me is that many of the other people that he recruited for the Manhattan Project were much more serious about the possibilities of communism and much more heavily involved with the Communist Party in a formal way than Oppenheimer ever was. And yet none of them was called before a committee and stripped of security clearance. This was well known. I mean, it wasn't anything that was secret, and it was never secret in Oppenheimer's case. I mean, he was very forthcoming about what his friends were like. His wife was a very active member. His girlfriend was a very active member, and so forth. So there's a lot going on that I'm not going to talk a lot about here, but it is the seeds of what ultimately brought him down as a public figure in some respect. This is hard to communicate effectively, but this is a part of a very long list of publications in physics journals by Oppenheimer and other people. These were taken in 26, 26, 26, 26. He was a student, a graduate student. 27, he was still a graduate student. Somewhere in 27, he got his PhD. But the one that's called 27D, that's on the quantum theory of molecules with Max Born. The Born-Oppenheimer approximation, as it's known, is still a part of the introduction to every quantum mechanics course taught. It's still the standard way in which you approach it, the quantum mechanics of molecules, even all these years later. So this is part of the fleshing out of the modern basis for understanding physics that's going on here. And Oppenheimer was not a tangential player. He was a major player in it. This is his Berkeley days, and this is an absolutely characteristic pose with a cigarette in his hand. And it eventually caught up with him. He died of cancer. This is another page. I mean, there's a long distance between the bottom of the page I just showed you and where I picked up here. These are now in the 30s. And if you look at 33B on the production of the positive electron, this is a paper that suggests that the work that Dirac had done might lead to a particle nobody had ever thought about, a particle just like the electron, which is a negative charge that has a positive charge. We call it a positron. 2 years later, Carl Anderson, an American physicist, discovered the positron. Okay. Let's see, is there anything else in here that goes on that line of research? And of course, most of the co-authors here are people who were his PhD students. This is later. And 1939A or 1938B on the stability of stellar neutron cores, on massive neutron cores. Those papers are planting the seeds for what we would call a neutron star. Neutron stars were not discovered until the 1970s. Okay, but he was predicting that could happen. These theoretical calculations would do it. 1939C on continued gravitational contraction. That's a paper that predicts the existence of black holes. And again, the criticism is that he just wandered from thing to thing that introduced him. He never actually developed all these things in depth. Well, he's thinking a lot on the broad scale here. And again, Julian Schwinger was one of his students, a brilliant physicist, whom I heard lecture on a couple of occasions. This is, again, the absolutely prototypical of picture of Oppenheimer as a teacher. Now I'm going to read a little bit to you from people who were part of his classes. Hans Bethe, who was actually more of a colleague, another Nobel Prize winner, said, and I'm quoting, "His lectures were a great experience for experimental as well as theoretical physicists. In addition to a superb literary style, he brought to them a degree of sophistication in physics previously unknown in the United States. Here was a man who obviously understood all the deep secrets of quantum mechanics, and yet it made it clear that the most important questions were unanswered. His earnestness and deep involvement gave his research students the same sense of challenge. He never gave his students the easy and superficial answers, but trained them to appreciate and work on the deep problems." Excuse me. Another student said, "First and most significantly, he always came to class well prepared, although he could have winged it with ease had he not devoted some advanced time to planning what he intended to present. I would not say anything nearly as complimentary about the professors who gave any of the other non-Oppenheimer physics graduate courses I took at Berkeley. At least one of these other professors usually came to class unprepared and floundered at the board. The remainder were well prepared, but in contrast to Oppenheimer, did not always have the course subject matter at their fingertips and could be rattled by questions. Oppenheimer gave no final exams or other tests. He did assign numerous homework problems, however, many of which were highly instructive and non-routine. They were always graded by Oppenheimer himself. Again, unlike the practice of a number of other Berkeley physics professors. I still have the homework problems, solutions I submitted in his advanced quantum mechanics course with his handwritten comments in the margin." Another student said he did not designate a textbook for any of his courses, nor did he assign readings or homework problems from any textbook. In fact, he only rarely explicitly cited any sources with the classroom material he presented. Another student talked about, "I undoubtedly learned far more physics from each of Oppenheimer's courses than I did from other graduate student courses I took. He was patient when students interrupted him. I have no recollection that he ever minded such interruptions. Rather, he generally would patiently address the question unless the question was manifestly stupid, in which event his response was likely to be caustic. Unfortunately, his patient answers were not always illuminating because he did not have the gift of putting himself in the student's place and recognizing that what was obvious to him might not be evident to the student. A student who persevered could expect to find himself on the receiving end of a very caustic sarcasm. But I must say that he never seemed to hold any grudge at students who momentarily attacked his patience. And as you might guess from this, I haven't mentioned probably the most distinctive feature of his lectures, namely his chain smoking. He spoke quite rapidly and puffed equally rapidly. When one fragment burned down to a cigarette burned down to a fragment he could no longer hold, he extinguished it and lit another in the single motion. I can still visualize his characteristic blackboard pose, one hand grasping a piece of chalk, the other dangling a cigarette, and his head wreathed in a cloud of smoke. So what has happened here, and what I really want to sort of get at today, is that Oppenheimer had created a nucleus of people around him. And then it became what we would consider the American school of theoretical physics. I'll show you a graphic in a moment, but prior to Oppenheimer, there were no American theoreticians in the pure physics area. He did this incredibly important research in astrophysics, in nuclear physics, in quantum field theory. He made important contributions in this long list of papers to the theory of cosmic ray showers, did work that eventually led towards descriptions of quantum tunneling, which is the notion of the fact that a charged particle is bound into the nucleus, should not be able to ever get out based on classical physics, but there's a probability factor that it will get out and become a nuclear decay product. In the 1930s, he, of course, as I said, he predicted black holes and neutron stars. That's an interesting thing because any one of those things, had he continued to work out the details, probably would have led to a Nobel Prize. In fact, Hans Bethe and another, I'm trying to think who the other Nobel Prize winner, basically said that had he lived until the discovery of these things, he would have been awarded a Nobel Prize. But they don't award any posthumous Nobel Prizes. This is the other really iconic photograph of him with the hat. This is a later picture. I think this is probably from the Institute for Advanced Studies era. This is one of his favorite vacation places was in the Caribbean. This is a family vacation. In 1940, he married Catherine Harrison, who had been a radical Berkeley student. And they had two children. Peter was the oldest one, and the daughter who came later. And by all accounts, he was a good father, and very much attentive to his family as he could be. And of course, during the 40s, it was difficult, and you get a sense again from the film of how difficult it was to live at Los Alamos with a family there. Let's see. That's his wife, who was very reticent to be in the public eye. There are not a lot of pictures of her, and that's by her preference. And again, his wife and children. Yeah. That's the woman that he had came close to marrying 3 times before their relationship broke up, and that's part of the explicit side of the movie that is true. They were not romantically involved after he was married, but that's Jean blank, I think. But she was another very socially activist person, another Berkeley student. Here he is with General Leslie Grove. Now, this, I think Robert Downey did an amazing job in the movie, but there is a difference in appearance between Leslie Grove and Robert Downey Jr. I could spend quite a bit of time citing the accolades of the people who worked with the Manhattan Project in terms of Oppenheimer's organizational skill and his ability to walk into a subgroup meeting, listen to what was going on, and go over to the blackboard and begin to sketch out the solution to the problem, whether it was in the metals part or in the neutron physics part or the trigger part. He was amazing in his ability to keep things on task and on time. It was an unbelievable project and worth perhaps if you're interested in much more close examination than I'm giving it here. Of course, it won him a Time magazine cover. It's in the 1945s. It might have been a 1945-46 Man of the Year after the war. Now, this is a list of to sort of help you understand what has happened. These are the internationally known American scientists prior to World War II. Okay, if you had gone into a university like Cambridge or Oxford and asked them who's doing science in America, these were the names pretty much that would have shown up. Now, by the 20s, the two great experimentalists, Robert Millikan and Arthur Holly Compton, would have been known also. But you recall when I talked about Einstein and others, I talked about the Solvay conferences, which pulled together all the theoretical physicists in the world. And in the 1927 Solvay conference, there was one American, and in the next, the one just prior to World War II in 1939, there was one American. Just so we've talked in this series about Franklin and Benjamin Thompson, who were both experimental people, experimental hands-on physicists, scientists. Joseph Henry was largely an experimentalist. He basically found the laws of electromagnetic induction at the same time Michael Faraday did. But Michael Faraday published in British journals and gets the credit for it, and rightly so, because he put it on a little bit different basis than Henry. A. Michelson was known for very precise measurements of the speed of light. He was at the Naval Academy as a faculty member, again an experimental physicist of the first order, and one of his experiments was a key part of the experimental evidence for the constancy of the speed of light that was part of Einstein's relativity. And he was the first American to get a Nobel Prize in 1907. His work was done in the late 1880s, 1890s. Josiah Willard Gibbs, most of you have not heard about. He contributed to chemistry, physics, mathematics, brilliant mind, late 19th century. Bridgman I mentioned, and now we have Millikan, Compton, Lawrence. And since Ernest Lawrence's in 1939, 85 Americans, not counting this year, have earned the Nobel Prize in Physics. So there's been a little bit of difference in in fact, a huge shift in where the world leadership in physics is. Even it remains so even with all the cuts in basic research. That machine is known as the ENIAC. You may recall that that was one of the milestones on the way to computers. The gentleman standing with Oppenheimer is a mathematician named John von Neumann. And von Neumann was a major contributor to the world of computers and cybernetics and mathematics. Brilliant mathematician. This may fail from a visual standpoint, but I found a sort of a family tree for scientists, and it's very interesting because that horizontal line are physicists, the top one, who were PhD students of Robert Oppenheimer. So that in a sense, they're his academic children. The bottom line are the students who are PhD students from, in this case, Willis Lamb. Okay? Now, Lamb won the Nobel Prize in the 1950s for it's a very subtle piece of quantum mechanics work that he did. The reason I know it's subtle is because I had that problem to work out, not mentioning Lamb on a PhD comprehensive exam, one of 5 problems that I had to do in 3 hours. And I couldn't get it to work, and the reason is because I didn't know about the Lamb shift and that you had to make this assumption that it just led to a Nobel Prize. But anyway, this is one piece, okay? This is another piece. David Bohm, who tried really hard to reshape the field of quantum physics, was one of Oppenheimer's students, and he taught not at a major research university, but he still had students who went on. This is yet another one. You can see that this is where the family tree comes down, Oppenheimer, and this is Philip Morrison, who taught at MIT and whom I had the opportunity to know a little bit many years ago. Brilliant physicist, brilliant lecturer, great man, just a lot of fun to be with. And those are his PhD students. That's what if you look at there were 33 of those things in this family tree. So he had, in a sense, 33 academic children, and they in turn nurtured 164 PhD academic grandchildren. So it gives you a sense, I hope, of the scope of Robert Oppenheimer in science as separate from the bomb. Because all of these graduate students were prior to World War II, all of the academic children, because after World War II, he continued to do some writing with people during the war off and on with what they could publish. But after the war, he was no longer in a position to be an active research physicist. I'll come back to this one in a minute. Just one more comment about the movie. You all know about his most famous quote, which is "I am become death." Here's what Oppenheimer said about that. He said that after they ignited the Trinity test of the first atomic bomb, nuclear bomb, he said, "We knew the world would not be the same. A few people laughed, a few people cried, most people were silent. I remembered the line from the Hindu scripture, the Bhagavad Gita, which, by the way, he had read in Sanskrit. Vishnu is trying to persuade the prince that he should do his duty, and to impress him takes on his multi-armed form and says, if the radiance of 1,000 suns were to burst into the sky, that would be like the splendor of the Mighty One. And then as the black-gray atomic cloud pushed higher above point zero, another line, I am become death, the shatterer of worlds, came to me from the same scripture. And actually, he's misquoting that other line, because the line is, time has become death, the shatterer of worlds, not I. But that's the way he did it. Well, anyway, again, as you probably know, he was, for largely political reasons, during the McCarthy era, subject to an Atomic Energy Commission scrutiny of his communist leanings, and humiliated in a public forum, which I listened to on the radio. I was really keenly interested in it, and did very little to defend himself. And I think that's brought out very well in the movie. His wife was really ardently a defender, but Oppenheimer himself didn't. And he had become the director of the Institute for Advanced Studies at Princeton, and he went back there and lived quietly until his death. Well, actually, he resigned a little bit before his death in 1966. But in December of 1963, and I do remember this also, well, actually it had happened earlier. It was in 1962, President Kennedy invited him to the White House to attend a White House dinner of Nobel Prize winners. And Kennedy had intended to award him the Fermi Medal, which is the highest medal that the Atomic Energy Commission in the day could award. But Kennedy was assassinated before that happened. Go back here, to come back to that bit. But this is that ceremony with Lyndon Johnson. It's a $50,000 tax-free award. And in his acceptance remarks, Oppenheimer commented, he says, I think it's just possible, Mr. President, that it has taken some charity and some courage for you to make this award. And at the Institute for Advanced Studies, he had some of the greatest scientists in the world working with him on their own individual research projects. And he continued to talk to people and advise people. He talked regularly to Einstein, who was a member of the Institute for Advanced Studies. He, I think, had just a quiet life at that point. He wrote some books, and I brought one of them somewhere. It's here. Science and the Common Understanding is one. Another one called The Open Mind, and some reflections on science and culture. He was a fellow of the National Academy of Arts and Sciences, the American Physical Society, Britain's Royal Society, the American Philosophical Society, and several other academies. Lots of honors came his way, but not until late in his life. And the sting of the McCarthy era was really, really hard for him, and for other scientists too. I don't know whether you can read that or not. He says, we are, of course, an ignorant lot. Even the best of us knows how to do only a very few things well. And of what is available in knowledge of fact, whether of science or of history, only the smallest part is in any one man's knowing. the greatest of the changes that science has brought us is the acuity of change, the greatest novelty, the extent of novelty. Short of rare times of great disasters, civilizations have not known such rapid alteration in the conditions of their life, such rapid flowering of many varying sciences, such rapid changes in the ideas we have about the world and one another. What has been true in the past of a great disaster or a great military feat for one people at one time is true for all of us now, in the sense that all of our ends have little in common with our beginnings. Within a lifetime, what we have learned at school has been rendered inadequate by new discoveries and new inventions. The ways that we learn in childhood are only meagerly adequate to the issues that we must meet in maturity. This was written in 1957 or so as part of a series of lectures. And I do really commend the book. This is my copy, which I don't see a price on it, $1.95, I think. That tells you something about it. Here are a couple other quotes. No man should escape our universities without knowing how little he knows. There must be no barriers for freedom of inquiry. There is no place for dogma in science. The scientist is free to, and must be free to ask any question, to doubt any assertion, to seek for any evidence, to correct any errors. And then both the man of science and the man of art live always at the edge of mystery, surrounded by it. Both, as a measure of their creation, have always had to do with the harmonization of what is new with what is familiar, with the balance between novelty and synthesis, with the struggle to make partial order in total chaos. This cannot be an easy life. Yeah. So, with that, what kinds of questions do you have or comments about Dr. Oppenheimer? Yarrow?
Yeah, I have two. One is, if you've never been to Los Alamos and you're in that area, you should go to Los Alamos. It's a very interesting place that's open to the public now. And one of the key exhibits they have there is the nail that he hung his hat on, that famous hat that he always wear. That nail is still in the wall at Los Alamos. It's also a mock-up of an atomic bomb there as well. The second thing is that in the last couple of weeks, the New York Times has published a long essay about atomic weapons that are currently in various countries' hands, with the footnote about how can we not expect somebody to use one of these one day. So it's you might want to look at that. You can, I mean, they'll let you look at that online.
Yeah.
And read that thing. So it's really goes. I mean, what they're talking about now is really what Oppenheimer was talking about in the security clearance business, which these other people really didn't understand.
Yeah.
So it's all come around full circle in a way.
Yeah, and one of the most disturbing scenes in the movie is absolutely true. The reaction of Harry Truman when Oppenheimer tried to talk to him about the bomb prior. Well, I don't know whether it's prior or post it's used, but no. If you read, and he wrote extensively about the dangers of not working towards some sort of worldwide system of keeping this thing under wraps. And he went to his grave with a serious sense of conscience about it. But as we well know, there were other people working on doing the same thing, and the science is there to be discovered. Somebody would figure it out. Just might have been later. But it is, and the scariest part is that, it may happen accidentally. There's, the more players there are, the more gaming there is, the more the chance of a miscalculation.
Well, recently, Putin has, again, I know I think about all this all the time because I was in the Air Force, and in those days we had bombers aloft which were carrying nuclear weapons, ready to fly over the pole and drop one on Russia. But recently Putin has suggested that if things don't go his way in Ukraine, he could use a tactical nuclear weapon. That's very scary stuff.
Yes. And I don't know what our predetermined response will be to that. I mean, I assume we have one. I'm sure the military has, knows exactly what it will do if it happens.
It's classified.
Yes. But it is a frightening thing.
Any other questions?
Einstein stayed pretty much out of it. Einstein was an avowed pacifist. He signed the letter that his mostly European colleagues wrote to President Roosevelt, telling them about developments in Germany that indicated that you could possibly do this, and that's when that was actually the beginnings of the planning that led to the Manhattan Project. But Einstein himself pretty much stayed out of it. I mean, he would talk to people. If somebody said, do you have any idea how to do this calculation or something, he would say so, but he was not part of the Manhattan Project, and wouldn't be. No, it's pretty clear where he stood on it. He was an avowed pacifist, and I don't know. I mean, he wrote some things. I can't quote them, but he wrote some things about the bomb, the use of the bomb, and after the war, after the fact, but not casting blame or anything, but just pointing out that it was not something that humanity ought to be playing around with. And Oppenheimer was not anti-nuclear per se. I mean, he was really heavily pushing what became Eisenhower's Atoms for Peace, the development of nuclear reactors, nuclear-powered ships, and other things, as opposed to weaponry. But yeah, and the technology for doing what was so laborious for us during World War II has evolved to where it's tabletop technology now. I mean, the separation of those isotopes could be done by people anywhere in the world very cheaply. So that probably means that there are countries who have at least prototype bombs that we don't even suspect have them. Yes, I'm sorry.
Do you have any idea what contribution Urey and Fermi, who were working with Oppenheimer back in his University of Chicago days, made?
Who?
Harold Urey and Enrico Fermi were both.
Oh yeah. Well, maybe I'll talk about Fermi in a future lecture. But Fermi and Urey was more of a chemist than but a very necessary part of the construction of the first reactor, which was what is a graphite-based reactor that I'm sure that Dr. Mays could tell us all the technical details on. But it was built in a squash court underneath the University of Chicago football stadium. And it's really quite a picture to imagine. You've got control rods that are essentially hanging from ropes that could be dropped into this thing by somebody cutting the ropes on short time, and Fermi's sitting there with a Geiger counter, basically monitoring the process of the nuclear reaction as the chain reaction begins and builds up energy. It was a pretty tense moment for the people who were in and around that, who knew what was going on, and there was very few people who knew what was going on. Graphite in this form is basically like pencil lead. It's in bricks. It's very slick and it's very messy. It'll come off on your hands. So everybody working in there had graphite dust all over them, in their lungs, I'm sure. Claude, you want to say anything more about that first nuclear reactor? Yeah.
Hang on, Claude.
Yeah, Claude said Fermi was much more important for the field of nuclear energy ultimately than Oppenheimer was. As nuclear energy, he was a brilliant both experimentalist and physicist. A theoretician rather. He could do theory and did, and also could do the experiments. Fascinating person. Well known for doing calculations on the back of his hand or on a postcard or whatever scrap of paper he could do.
Well, that reactor was the beginning of the Trinity bomb was a plutonium,
Yeah,
and of course you have to have a reactor to get the plutonium, and it was the beginning of the Hanford reactors where they got the plutonium for the first bomb. Came from the work that Fermi did,
yeah.
and well, we were like, this is just a side note. We worried about Iran having a bomb, the uranium bomb. I would bet you any amount of money they've had a plutonium bomb
Oh yeah, I'm
for
sure.
many years because they've had reactors, and it's not that it's much easier to build a plutonium bomb than it is a uranium bomb.
Yeah. Yeah, that's true. The technology has just made it almost laughable in terms of how easy it is if you can get the material, and it's not that hard to get the fissionable material, especially plutonium. And the other interesting thing about plutonium is not only is it an interesting bomb material, but it's highly toxic. You know, an aerosol piece of plutonium ingested into your lungs is enough to start lung cancer. Plutonium dust is not something you want to breathe. But Harold Urey was a really well-known chemist, and there are some interesting chemistry problems, including some of the attempts to do isotope separation and other things that Urey was involved in. And there, you know, the famous line from Telegraph, the Italian navigator has landed, was the code word for the fact that we were successful in making that reactor, the chain reaction, and stopping it.
I have one other historical note, if you're interested in computers and that stuff. ENAC, you showed a picture of ENAC.
Hold on, just so everybody can hear you.
ENAC is a huge machine, and it's still at the University of Pennsylvania, and you can go visit it if you're in Philadelphia.
And there was the successor for ENIAC was called Maniac.
Any other questions? Hold on, Claude, because we can't hear you.
What you mentioned Jesse Beams earlier.
Yeah.
He was also on my master's defense, but we're using his technique now to separate that,
Yes.
to enrich uranium.
That's an interesting point, and I have my own theory about it, but it's just a theory. Dr. Beams was a brilliant experimental physicist and the epitome of a Virginia gentleman, if there ever was one. But he was in his, I guess, 70s when we were students there, still doing 12 hours a day of research and expecting his students to do 15 to 16 hours a day of research. But as we began the Manhattan Project, they asked Dr. Beams to test the feasibility of using high-speed centrifuges, which he had pioneered the develop to do isotope separation. Basically, his centrifuges are metal rotators that were suspended in a magnetic field, and so they were basically frictionless except for air friction, and you could crank them up to very high speeds and get enormous forces in there to separate densities and stuff. And Dr. Beams concluded that you couldn't do it, or it wouldn't be feasible to do it. And I don't believe that he believed that for a minute. I think he found out how easy it was to do it. That's my feeling, because he could not have missed the fact that now that's the only way that pretty much that you separate the isotopes is through ultracentrifuges. And that's why I says tabletop. I mean, doesn't require any big equipment or reactor or anything else to do it. But I think he's just too sharp an experimentalist to have missed that. But that's my conjecture. But he concluded that it wasn't feasible, and so we built, 100-acre buildings at Oak Ridge and Hanford and at Lawrence in California. The cyclotron that I mentioned was important in separation early on.
And in fact, for the uranium bomb, they started with the cyclotron and enriched it up to a certain point. Then it went into gaseous diffusion.
Yeah, at Oak Ridge.
Right.
So yeah, all these things played a role in it. It's a very, very complex network of stuff, and there are just lots of pieces to the Manhattan Project. The computer piece is one of them for big time number crunching and the push to do that, both from the standpoint of code breaking on one side, but also from just pure number crunching for doing calculations for the Manhattan Project.
I want to say how much, as a non-scientist, this series of lectures has meant to me. This
Well,
has been
thank
a
you.
wonderful introduction to many things that I wish I had known much earlier in my life. Thank you for doing the lectures, and thank you, Susan, for offering us this kind of intellectual stimulation. It's been wonderful.
Glad you enjoyed it, Elizabeth.
Well, that's very kind of you. Thank you. I can assure you it was equally stimulating, if not more so, for me.
Did you say when the date of that movie would be?
She said 2 weeks from now.
It's 2 weeks from today, Hawk. Yeah, 2 o'clock here in the Commons. So it'll take us on till dinner time.
Okay, well, thank you.
All right, thank you.